Let's get into chapter 12.2, differentiation and integration of vector value functions. And in this section, we're gonna learn how to differentiate a vector value function and integrate a vector value function. So let's learn how to differentiate the vector value functions first. When you take a differentiation of vector value function, you have to take derivatives of all the components of the vector value function, which means you have to find the derivative of f of t, g of t, and h of t for I, j, and k. Let's take a look at these two questions. So question A, we take derivative of 2 squared and 4, which is r prime of t equals to 2t times I, 2ti minus 0j, and then the answer is 2ti. And question B, r prime equals to the derivative of 1 over t is negative 1t squared I plus the derivative of ln t, 1 over tj plus the derivative of e to 2t equals to 2 times e to 2 times t, k. And here's our answer. And here are some properties of derivative of function, vector value function. And when you do questions, you will need to use these properties. Let's take a look at this question. We need to find the derivative of the dot product of r of t and u of t. The first thing we get is r prime of t equals to negative 1 over t squared I plus 1 over t k, and u prime of t equals to 2ti minus 2j. And according to properties of derivative, we know the derivative of the dot product of r of t and u of t equals to the dot product of r of t and u prime t plus the dot product of r prime t and u t. Then we know the derivative of dot product of r of t and u of t equals to 1 over ti minus j plus ln tk dot 2ti minus 2j plus negative 1 over t to the second I and plus 1 over tk dot 2 squared I minus 2tj plus tk, and it equals to 2 plus 2 minus 1 plus 1 over t. And then we get the final answer, 3 plus 1 over t. And taking the integration of vector value function is similar to find the derivative of vector value function, because you just need to find the integration of every single part of the vector value function, and then you get the integration of the vector value function. Let's do example 7, finding the antiderivative of vector value functions. Based on the question, we can find out the antiderivative r of t equals to the integration of r prime t dt, and we take an antiderivative of every part, and we find 1 over 2 sine 2t plus c1i plus 2 cosine t plus c2j and inverse tangent t plus c3k. Then we let t equals to 0, and we find r of t equals to 3i minus 2j plus t. Then we can equate the corresponding components of C1 equals to 3, 2 plus C2 then equals to negative 2, and C3 equals to 1. Eventually, we find the antiderivative that satisfies the given initial condition. R of t equals to 1 over 2 sine 2t plus 3, C1. I plus 2 cosine t minus C2, which is negative 4, and plus inverse tangent t plus 1 C3 k.